Assalamu alaikum. It's our next lecture of particle physics in which we are going to solve problem number 5.4 from chapter number 5 of book Griffiths. What it says, using the equation which is given to express the kinetic energy T equals to E minus mc square. Okay, in terms of P and M, what you have to do to have to show that the lowest order relativistic correction approximately equals to T equals to P square by 2m minus P4 divided by am cube c square. So this is you have to show and express your kinetic energy term in this relation. So let's solve our problem. You will start your problem by the equations of Einstein. You know that the relativistic term of Einstein equation is basically equals to E square equals to P square C square plus m square C power 4. This is the relativistic Einstein's energy equation. Okay, let's take the under root and taking C common, so you will left with uh, E square becomes equals to, you can take C square common, P square plus m square C square. After taking the square root, okay, what you will get basically equals to C under root, or you can say that here is P square plus m square C square power 1 by 2. Now what you have to do here, you have to take common m square C square, you have to take common. By taking common, so E becomes equals to, okay, by taking common, or you can say that here is C, you can take in common, so the common means you have to divide it by m square C square, which I mentioned you here, plus m square C square, m square C square 1 by 2, because you take it as common. So once it's come out, because there is also power, so it becomes mc square, m square C square power 1 by 2. So taking square common and cancels, you will get mc, and mc multiplied by this c becomes mc square, and this becomes 1 plus p square by m square c square. So this is your relation. Now you have to express this by binomial expansion. You know how you can expand binomial expression. You know that, let's suppose 1 plus summation power 1 by 2 can be expanded by 1 plus power, which is 1 by 2 epsilon minus 1 by 8, because you know that here is 2 factorial, here is 3 factorial. Okay, 1 by 2 multiply by 2 factorial. Okay, so it becomes 1 over 8. Okay, epsilon square, plus you can ignore the higher order terms. Now what you have to do here, your this is 1 and your epsilon is this is your epsilon value. You can mention here your epsilon is equals to p square by m square C square is basically the epsilon, and this is 1. You can only apply your binomial expansion here. So what you have to do, just put the value of epsilon here, so you will get your relation 1 plus p square by m square C square. Okay, this becomes equals to what, 1 plus, okay, here is also 1 by 2 here. Okay, 1 by 2 here, 1 plus 1 by 2 p square divided by m square C square minus p square square, because there is square of epsilon, 8 becomes m4, because m square m4 and c 4, plus you can ignore the higher order terms. Understood? Now what you have to do, you have to put this value in this relation of Einstein. Okay, so you will left with E equals to mc square multiplies by 1 plus p square divided by 2m square c square minus p4 8 m4 c4 plus you can ignore the higher order terms. Understood? Now you just have to multiply mc square inside. You will get mc square plus p square. Okay, m cancels with 1m, c square cancels with d. You will only left with p by 2m minus p4 divided by 8. M cancels with 1m. You will get with m cube here, and 1 c square cancels with c4. You will left with c2. Ignore higher order terms. Now move this mc square to the left side. E minus mc square, which is equals to p square by 2m minus p4 divided by 8m square c square. And this is mentioned in the question that E minus mc square is basically the kinetic energy term T. E minus mc square basically equals to the kinetic energy term T, which is equals to p square by 2m minus p4 divided by 8m square c square. So this is your result of the kinetic energy term correlation, which is the lowest order relativistic correction to our kinetic energy term for this problem. So that's all for this problem. How you can solve problem 5.4 of book Griffiths of the course of the particle physics 2, and this is how you can find the uh, kinetic energy term and the lowest order relativistic correction, which approach is equals to this. Here is m cube. Okay, here is m cube, because 1m cancels with this, you will left with m cube. Here is also m cube. So this is final your answer, which you have to prove. So that's all for today. So stay tuned with us. We will upload more interesting videos of the course of particle physics. Until then, take care and Allah Hafiz.